In this question, you're given that the matrix A is 0, 1, 0, 0. You're asked to show that some constant A times I plus some other constant B times A power n will always be equal to A power n times I plus n A to the power n minus 1 into B times A. So you're asked to prove this statement for all n belongs to natural numbers. So in such type of questions, we use the process of induction. Induction is one way to prove the statements in the set of natural numbers. So what is the first step in mathematical induction? We need to check whether the statement is true for n is equal to 1. So for n is equal to 1, what does the statement become? So AI plus BA power 1 is equal to, if you put n is equal to 1 in the right hand side also, A power 1 times I plus 1 times A power 1 minus 1 times B times A. This is nothing but AI plus A power 0 is 1. So 1 into 1 is 1 times BA. So AI plus BA power 1 is same as AI plus BA. This side is also equal to AI plus BA. Hence, the statement is true for n is equal to 1. The statement is true for n is equal to 1. It's clear till now. What is the second step? We assume that the statement is true for some n is equal to m. So assume the statement to be true for n is equal to some m. For some natural number, let us assume that the statement is true. That is, I'll assume that AI plus BA power m is equal to A power m times I plus m A power m minus 1 times B. So I'll assume that this is true. Now, once you assume that this is true, you need to prove that the statement is true for the next number m plus 1. So the statement for n is equal to m plus 1 is, so I'll write this statement which you need to prove that it holds good. That is, you need to prove that AI plus BA whole power m plus 1 is equal to A power m plus 1 times I plus m plus 1 times A power m times BA. So this is the statement which you need to prove. So I'm assuming that this is true and I need to prove this. So let us start from the LHS. So AI plus BA power m plus 1 is same as AI plus BA power m times AI plus BA. That is equal to, so what is AI plus BA whole power m according to our assumption? This statement is A power m times I plus m times A power m minus 1 times BA times AI plus B. So that is equal to, so you know that in matrices bracket can be expanded as long as you don't change the order of the matrices. So A power m times I times AI. So A power m plus 1 times I square, I into I is I square, plus, let us multiply these two. M times A power m minus 1 into A is A power m times B AI plus. So I multiplied this with the first term, second term with the first term. Now the next multiplication. A power m times B, these two are constants. I and A are matrices. Plus, let us multiply these two. m times a power m minus 1 times b into b is b square times a square. B square times a square. So that is equal to. So keep it clear in your mind where you need to take this statement. So I square is nothing but I. So a power m plus 1 times I plus, so m into a power m, b, ai, I is the identity matrix, so ai will be same as a, ia will also be same as a. So this is also the matrix A, this is also the matrix A. So I can take A as common. So I will take the constants m a power mb, a power mb. So a power mb times m plus 1, right? So if I take a power m into b as common, you get m plus 1 times I plus m times a power m minus 1 times b square times a square. So just look at where you need to take this. A power m plus 1 into I, a power m plus 1 into I, m plus 1, a power m ba, m plus 1, a power m ba. So this is the term which you don't need, but you got this extra term. That means this statement is not valid for every matrix A. So in the question you're given that A is 0, 1, 0, 0. So let us see what a square is. A square is nothing but 0, 1, 0, 0 times 0, 1, 0, 0. This is equal to, you know the matrix multiplication, 0, 0, 0, 0. So a square is a 0 matrix. So this all these are scalars. So any scalar multiplied by 0 matrix gives you a 0 matrix. So this whole thing is a 0 matrix, that is equal to a power m plus 1 times I plus a power m b m plus 1 times a. So we have proved that the LHS for n is equal to m plus 1 is equal to the RHS. Hence, the statement is true for n is equal to m plus 1. Hence, the statement is true for n is equal to m plus 1. Hence, by principle of mathematical induction, the statement is true for all n belongs to natural numbers. So that's the proof of this question. Thank you.